Hi and Assalamualaikum. My name is Shafiq Hidayat bin Johan. This is the presentation for experiment 7 from group 5. This group consists of 4 members, that is Hanan Delisha binti Elfi, Nurul Azwa binti Kamal, Muhammad Amir Ashraf bin Muhammad Nazali, and myself. Let me start with the introduction for this experiment. So this experiment will require us to have the understanding of heat capacity and entropy change. Heat capacity is amount of heat energy required to raise the temperature of a substance per unit degree. There are two main types of heat capacity, which are specific heat capacity and molar heat capacity. Substances with higher heat capacity require more energy to change their temperature. Entropy change is a measure of change in disorder or randomness in a system that undergoes process. The entropy generated during a process is called entropy generation and is denoted by Sgen. When heat is added to a system, the entropy increases. To relate with the daily basis, we can look at the picture endothermic. When heat is added to the ice, the entropy will be increased. The objectives of this experiment is to estimate the heat capacity C of different metals provided and to estimate the entropy generated when these metals are dropped in a beaker containing corn oil. So the scope will be 3 different metals, that is steel, aluminium and copper, and the temperature range between room temperature to 100 degrees Celsius.
Theory of working principles. The amount of heat needed to increase a body's temperature by 1 degree Celsius is known as heat capacity. As two bodies with different temperatures exchange heat, the amount of heat lost by the warmer body equals the amount of heat gained by the cooler body, and an intermediate equilibrium temperature is achieved. This is valid as long as no heat is lost to the surrounding. A heated solid with known mass m and temperature is lowered into a calorimeter containing known mass m2 of coin oil in this experiment. After that, then only the equilibrium temperature is determined. The amount of heat lost by the solid must be the same as the amount of heat gained by the corn oil. So this is the formula used to find the heat lost by the solid and also heat gained by the corn oil. The entropy changes of a system or its surrounding can be negative, but total entropy generation is positive. A process must proceed in the direction that complies with the increase of entropy principle Sgen more than zero. The entropy generation is a measure of the magnitude of the irreversibilities present during the process. The entropy generated during this process is determined from this formula.
Assalamualaikum, my name is Hanan Delisha and I will be explaining the experimental setup. Okay, so for the experimental setup, we need aluminium foil, digital thermometer, 2 beakers, metal string, 3 metals which is aluminium, steel and copper, hot plate, weighing scale, digital stopwatch and corn oil.
So the first step of the experiment is the copper metal is weighed using the electronic balance, and then the second step is pour 80 ml of oil into the first beaker and heat it by using the thermoplate. The third step, the weighted copper metal is submerged fully into the 80 ml oil using a metal string, and then the copper metal is heated in the oil bath until the oil reaches 200 degrees Celsius. Next, the second beaker is filled with also 80 ml of oil, and the initial temperature of the oil is measured and recorded. The sixth step is the temperature of oil in the first beaker. When it reaches 200 degrees Celsius, the copper metal is immediately transferred into the second beaker. And the seventh step is the second beaker is covered using the aluminum foil cap. The temperature of oil in the second beaker is measured and recorded at every 10 seconds intervals until the constant temperature is reached, and then the oil is stirred throughout the process. Lastly, the procedures are repeated using different metals, which is copper, which is aluminium and steel. So these are the results that we obtained from the experiment. This is our expected result of how the equilibrium temperature is obtained for each metals. And these are the table of our experimental result when we do the experiment. And this is our calculation throughout the experiment. So to find the entropy of metal, we use the formula of mass metal times Ct of metal times ln the temperature, the last temperature T2 divided by T1, the first temperature. So for copper, the mass of copper that we use is 0.069 kilogram, and then times 0.385, which is the Cp of copper, and then that's the temperature, referring to the table of our result. And then that is for iron and also aluminium. The entropy change of oil is mass of oil times Cp of oil, and then times ln the last temperature divided by the first temperature. So those are the result of our calculation.
Assalamualaikum, my name is Hana Delisha and I will be explaining for the safety procedure. So for the safety procedure, firstly we need to ensure protective equipment such as heat-resistant gloves, lab coats and closed-toe shoes are in good condition and used during experiment. Secondly, check for any kind of cracks in glassware and thermometer to avoid any harm during the experiment. Third, use tongs or heat-resistant gloves when handling heated items such as beaker or metals. And lastly, dispose waste properly such as broken glass or the substance used in the experiment.
Discussion of this experiment. From the experiment, the values of the heat capacity of each of the metals is determined and was shown in table. From the table, it is observed that the iron has the highest heat capacity, followed by aluminium and copper. Heat capacity, which is defined as the amount of heat needed to raise the temperature of 1 gram of the substance by 1 degree Celsius, is dependent on the atomic mass of the metal. Hence, iron has the highest specific heat capacity because less energy is required to heat up 1 gram of the metal, since there are fewer atoms per 1 gram of mass with higher atomic masses. From the calculation of total entropy, the results for copper, iron and aluminium are 2.91 times 10 to the power of negative 4, 2.061 times 10 to the power of negative 4 and 2.523 times 10 to the power of negative 4 respectively. All the entropy values that are calculated are known to be positive, which complies with the knowledge that has been learned in thermodynamics. During a process, the entropy of an isolated system is always in the limiting situation of a reversible process, and it is either increases or stays the same but never decreases. This is known as the increases of entropy principle. Negative entropy changes can occur in a system or its surrounding, but not in entropy generation. It is observed that the highest entropy transfer in the copper and lowest in iron. From the result, it can be concluded that the higher the heat capacity of a substance is, the lower the entropy generation it has.
So for this experiment, the heat capacity of 3 different metals, aluminium, copper and iron, was estimated by measuring the final equilibrium temperature after each metal was dropped into the oil, and the total entropy generated during the process was calculated. So the entropy generation for each of the metals are as shown.
Since entropy generation is a reflection of irreversibility, then aluminum must have experienced more irreversibility during the heat transfer process. This could be attributed to its higher heat capacity, which may have caused greater heat transfer and hence greater amount of irreversible change. The total entropy generation underlined the second law of thermodynamics, which is that even in a simple heat exchange, irreversibility occurs. This emphasizes how important it is to control thermal process in order to minimize energy losses in real-world applications.